Next Curve.
Welcome to this Next Curve Rethink podcast episode where we break down the latest tech and industry events and happenings into the insights that matter from the world of semiconductors and AI. And this is the Silicon Futures series that we do. And I'm Leonard Lee, executive analyst at Next Curve, and I'm joined by the perplexity augmented Karl Freund of Cambrian-AI Research, and we have the supercharged, custom-built Jim McGregor of famed Tirius Research. How are you guys doing?
Doing great. Looking forward to the weekend.
Awesome.
Oh, yeah. It's not a weekend yet. Yeah.
Yeah, and so people don't know and probably don't care that this is a Redux episode. We had a technical issue with the original recording. So all insights that we share here are actually a week old. So we just want you to know how current we are. It's just
I think we should fire the host.
Yeah.
Good luck. Good luck, Jim. Oh my gosh. Okay, you guys are ridiculous. Okay, but before we get started, remember to...
No, that's a whole nother show.
Please remember to like, share, and react and comment on this episode. Also subscribe here on YouTube and Buzzsprout. Opinions and statements by my guests are their own and don't reflect mine or those of Next Curve. And we are doing this to provide an open forum for discussion and debate on all things, AI and semiconductor industry stuff. So in this installment, this is a little bit of offbeat. This is like a talk. Talk. This is a talk episode for the month, just because so much stuff has been happening. Don't shake your head, man. What the hell's your problem? But there's a lot of stuff that, there's like so much stuff. Most prominent is Karl's Forbes piece, which we're going to give Karl an opportunity to basically reprimand everybody who didn't go with Nvidia for their AI. We're going to let you have an opportunity to just go to town with that, okay? So, hey, Karl, let's start off with your piece.
Okay.
I had a chance to read it, by the way. I loved it, even though, it rubbed me the wrong way in certain areas. But, that's common between you and I, right? But
right.
I thought it was...
Is that too much information?
Way too much information.
Way too much information.
Yeah. Karl,
The basic premise is pretty simple. Companies are spending billions of dollars to not buy NVIDIA products that work, and they're trying to compete with them. And I understand why. They don't want to spend the high price. They don't want to be locked into a single vendor. Got all that. But there's a price to be paid. And the examples I gave were things like Apple, which has a ABN strategy, anybody but NVIDIA. Had they simply used NVIDIA, maybe Siri wouldn't be 2 years late, which it will be at least. Now, they have some technical issues as well. I don't mean to minimize those, and they're not easy to solve. They have an installed base. Oh, yes. Yeah, generative AI Siri will be 2 years late, according to Apple.
Okay. All right.
Okay. Yeah, so had they just used NVIDIA, would they be on schedule? Who knows? AWS is spending a large fortune on Trainium and Inferentia. I get why. But it's interesting how much trouble they have with their own engineers and other engineers that they kind of shove Trainium down their throats. Trainium 2 is not competitive with Blackwell. Maybe Trainium 3 will be, but then NVIDIA will be on to Blackwell Ultra, right? But more importantly is the software stack. It's really about CUDA. I was talking to a developer who left NVIDIA, who will remain nameless. He's with another cloud provider now. And he said when management told them they had to use Trainium, they said, okay, we will. We will be late to market. It will cost more to develop the software. And you want us to do this? Why? And so forth. Now they're building massive clusters of Trainiums. And we'll see how well that goes. So the article is basically just kind of a wake-up call to people. Say, don't assume that your engineers know how to build a better AI chip than Nvidia. In fact, I would claim they do not. And more importantly, they don't know how to build rack scale infrastructure. There's only one rack scale infrastructure available today, and that's Nvidia, unless you want to buy Cerebras, which isn't really rack scale, but it's that big and it's that expensive, right? Yeah, they can scale, but it's not cheap. It's very good, but
It's like
not
buying a
cheap.
supercomputer, yeah.
It's buying the smallest supercomputer ever built. Exactly, Jim. So that was really the article about it. I just wanted to kind of shake everybody up and say, you know what? There's no free lunch here.
Yeah.
Well,
And
and there's
I am sure they'll solve their problems. I'm sure Apple will eventually have an Apple Intelligence, which is also called AI. And I'm sure that Trainium eventually will be a good chip, but it's going to take years, and it's going to take many, many tens of billions of dollars just so that you can be late to the party.
And that's only one side of the equation. The other side of the equation are the developers. If the developers aren't accustomed to that platform, aren't developing on that platform, it's not going to be effective. It's not going to be cost effective to use the platform. Matter of fact, we're seeing that, just in the number of Nvidia GPUs deployed is making a huge difference in terms of who's winning and losing in terms of those instances for AI out there in the marketplace today.
Mm-hmm. And you call me perplexity augmented. Guess what perplexity uses? NVIDIA only. Why? Because it's the best. It's the best hardware. It's the best software. It's the best rack scale infrastructure. And they've got more stuff coming out at Hot Chips next week. Keep an eye out for what they're going to announce.
We're all going, right? I'm going to be there.
I'll be there.
I'm gonna be on phone. I'm just not interested in traveling out there.
Really?
Yeah, I'm just gonna do it remotely. You get better screenshots.
I won't argue that one.
Yeah, bro.
Yeah. So that was it. Take a look at it. You can see it on CamrionAI.com as of Friday, I believe. And you can look if you have a Forbes subscription. You can look at it on Forbes right now.
Yeah. No, it's it was well done. I mean, it does beg the question: what would be the alternative play? I mean, that was the thought-provoking aspect of the piece, Carl. So yeah.
I think the better place is get your AI product to market as quickly as you can. Yeah. And building your own chip is not the way to do it. Now, there are some chips that I wouldn't put into the same kettle of fish, right? Such as what Meta has built, right? That's to solve a very specific problem they couldn't really solve the way they wanted to solve it with GPUs, and so it's for recommendation engines. Yeah. And if you have a use case and designing your own chip makes business sense, good luck. I think it's great. And competition's good. I think Trainium 3 is going to be a good platform. But I just wanted to point out that there is no free lunch. And these are very expensive products. The other one I would make an exception for is TPU, because Google's got more money than God, and they know most gods, right? And so they can afford to do this, and they have enough workload to make these spreadsheets all work out in a good way. They're positive. So nothing against TPU, but all the Trainium stuff and Inferentia and the list is long.
The funny part about this is there's a historical trend here, and the fact that companies trying to do their own ASICs usually doesn't last very long, because more than a few generations, because it's really hard to keep pace with people that develop silicon every single day.
That's all they do.
It's impossible to keep up, especially when there's an annual cadence for companies to keep up with that cadence and keep pace with technology. So historically, we've always seen this. It is really hard unless you're investing in having a full silicon solutions group that is just focused on developing a new chip constantly. And usually you have to have multiple generations going simultaneously. And that's a huge challenge and a
Yeah.
huge investment. So I agree with you, Carl. It's hard
Yeah.
to
And
do.
the day I published it, Microsoft announced that their next generation AI chip's going to be late.
Yeah.
And I haven't met too many developers who are using what they have today because it's just not competitive.
Yeah. 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 And but there's also that scale element though, right? And we're talking about systems more than we are the chips these days, right? And so that's one of
Yeah,
the
and
things that I've
software.
noticed is as people continue to talk about AI supercomputing, there's still a fixation on the accelerator itself. But it's been months, if not a year and a half at least, since we've graduated from that notion. Jim, you mentioned rack scale. I in many of the conversations that I've had outside of, let's say, this hyper focused, group of folks hyper focused on AI supercomputing, they haven't graduated their thinking to the rack yet, much less the data center. And so these different levels and scales of AI compute are still fixated on the smallest unit, which is the quote unquote GPU or the chip or the accelerator. So, and as we look at the landscape, though, it's still diverse. I mean, ASICs and custom systems, right, on top of custom silicon, still a thing. Although I think Nvidia is making some really interesting plays, especially on the networking side, right?
Yeah,
But it's
I
getting
totally agree.
complex, and I think a lot of audiences are still behind the kind of perspective that we present. Do you know what I'm saying? For us, it may be totally obvious. I'm telling you, outside of this small group of folks who are breathing this, sub industry or industry day in and day out, it is so not obvious, right?
Mhm.
So I think the piece that you put together, Karl, really good, thought provoking, and thanks for sharing it. And everyone, check it out. It's like friggin' awesome. So let's move on to our next topic, which is all this drama around Intel. We have the Trump administration or Trump himself telling Lip-Bu Tan to take a hike because of quote unquote conflicts, and then Lip-Bu makes a visit to the White House, and next thing you know, he's like a success. And then,
Everybody's
yeah, now we have the U.S. government, or talk about the U.S. government taking a stake in Intel, in sort of, I don't know if you want to call it in lieu of the CHIPS Act grant funding that they had been earmarked for, but then also SoftBank stepping in with, I think it's like $2 billion, right? What do you guys think? What's going on?
I think the Trump administration is trying to renegotiate the CHIP Act. They're trying to say, "Oh, that money we promised you, there are strings attached." And I think Intel is the first of many that will
Hey,
suffer that. So Samsung and others are going to probably have their moment in the Oval Office, where they're going to be forced to give something up to get what has already been promised to them.
that is a very interesting point of view right there that you just shared. Yeah. It's a renegotiation of the CHIPS Act. Yeah. It's interesting. Jim, what do you think? What's your reaction?
My reaction, I wasn't really that surprised. Intel is important to our country and our industry in many levels, not just the products, but the importance of having, they're the only option we really have for having a U.S. Leading edge foundry.
Yeah.
Which is necessary, especially for defense and government applications, but also the fact that Intel's been critical to our industry, especially from an R&D standpoint. There's so many technologies we wouldn't have, even some that they contributed to but didn't come out with, like silicon, like co-packaged optics and stuff like that. But when you look at 300 millimeter wafers, EUV, high NA, FinFET, gate all around, all these technologies, we probably wouldn't have without Intel. So they are a critical kind of foundation of our industry. And I think that we do need to see them survive. So having the government step in and say, okay, well, we need to make sure that they're around. I kind of agree with. I don't think it's a long-term thing. I think it's kind of they're looking at it. Let's face it, this administration looks at how do I make money, and kind of looking at what happened with the GM bailout. Get in, make money, get out. So I kind of view it from that standpoint. I don't think it really impacts the market. It doesn't really impact Intel's product roadmap or anything else long term. I think it just kind of gives them a cushion that they need to actually, get over the hump.
Yeah,
Gives them a bridge, gives them a bridge to the future, gives them financial underpinning they need to do what the U.S. industry really requires of them, which is to be a competitive foundry.
Yeah.
Yeah, and from a cash flow standpoint, yeah, definitely the infusion is going to be essential given what now is apparently a not too healthy situation. I think coming into 2025, I think the perception was, yes, they have issues, but maybe the situation was salvageable, that their roadmaps were on track. And, Jim, you've mentioned how the PDK was late and how there were some slip ups that have landed them in a less than optimal situation where they really needed to be optimal, especially coming in with the ramp into 2025 with the ramp up of 18A, and then probably very importantly, if not essential, the a successful launch and wrap up of Panther Lake. So yeah, it's been a bit of an eye opener, and it's just that I think we haven't had a very good track record with government intervention or this industrial policy being instituted in the semiconductor industry, because one of the red flags for me is how policymakers talk about the semiconductor industry. It's indicative of the level of understanding that they have. And the big problem here is the semiconductor industry for folks that are on the outside is very much the most it's the industry that has that is prone to the most severe unintended consequences, right?
Yeah.
This is the problem. And one of the reasons why my confidence level in a lot of this intervention is low. And I also think that market forces at the moment are probably an important cleansing mechanism for a lot of the trouble that Intel's in at the moment. So anyways, that's my 2 cents.
I would agree with you. I don't trust anybody that can't even spell technology like AI, which
how do you spell that?
Basically Washington, or they put a hyphen in semiconductor, or when they start talking about silicone instead of silicon.
Well, that is explainable, but
I know it didn't. No, it isn't. No, so I agree with you. That I would rather. I think the government has a role. Definitely in our industry, there's got to be regulations. There's got to be, and I think they should encourage innovation. And there's better ways to encourage innovation than direct investment or control or anything like that. I just think we got caught in Intel, especially, is in this situation where, unfortunately, let's face it, they went through a couple of different leaders that didn't really have a vision for the company. And the company faltered in terms of some of its products, some of its roadmaps, and everything else. Intel's still very important to us, and we don't have another option for them right now. So
totally agree with that.
It's not that they're too big to fail, but we can't afford for them to fail.
Yeah, they're too important,
and
to
we
allow
really
to
can't
fail.
afford to break them up at this point in time. The foundry's not competitive, so until we see
and their
Intel.
chips. They still don't have a competitive AI platform. It's 2025. Yeah. They're not going to have a competitive AI platform. We should hear from what leadership has said. We should hear fairly soon what their new AI strategy is going to be. I'm anxious to hear that.
Mm.
and I'll be all ears. But so far, this will be their fifth try at building an AI chip.
Yeah, and and for the audience, if you want some of our retrospective thinking about this, check out our episode, which we taped at a bar in Las Vegas during Intel
Vision, yeah.
25. It's a good one. It's a good one. We had David Altavilla on as well, who shared his perspective, and it was fun. And we had drinks afterwards, I think, right? If I'm not mistaken. I
Might have.
Okay. Anyway.
Or were we drinking before? I don't know.
Both, probably.
Not during. Not during.
So speaking of, the U.S. government and the semiconductor industry, another hot item of the last week or two has been the Nvidia and AMD Trump. You want to call it a tax? I don't know.
It's a tax. It's a tax.
It's an export tax.
It's a tax on AI chips sold to China. So,
Well,
this one on.
First, you can sell to China. No, you can't sell to China. Oh, we'll let you sell to China, but you have to give us 15%. Yeah, that's going to backfire. Not only is that bad for those companies and kind of a bad precedent to set for the industry, but China was not happy about it. So they're telling companies to stay. The Chinese government is telling companies to stay away from them.
Mm-hmm. Yeah, the opportunity may evaporate. There's a lot of speculation whether Nvidia will even include China in their forecast when they announce earnings. Mm-hmm. I'm guessing they won't. They'll play it safe and say, we don't know if they're going to buy it. We don't know if we're going to be allowed to sell it, so we're not going to include that in our forecast. Even though they're building a specific chip beyond the H20, a Blackwell-based solution. P20 or whatever they're going to call it.
Yeah. This has been a really strange one, and in particular, the confluence of different perspectives on both sides of the Pacific, right? Where the Chinese government is now surfacing a lot of security-related concerns, right? So, the national security concern is a double-edged blade, right? It cuts both ways, and I think one of the things that we don't think about generally is the concerns of the other side, right? And that things like national security also actually are an agenda for the Chinese government, right? Mm-hmm. And that sometimes falls out of the calculus of how people think about how the market plays out. They just tend to think in terms of U.S. national security and technological security. And so this is an interesting moment where we're seeing now the Chinese government assert itself and its influence on the AI market for these chips that may be counterintuitive for some folks, right? They might think, oh, well, the demand is so high, of course they're going to buy all these chips. And it's something that I mentioned in a couple of episodes ago. Actually, may have been in like March or February, that the allowance, the permitting of these sales may not turn out the way that folks think, right? That a dynamic like this would play out. And so this is what we're seeing happening right now. But I think what's more interesting now is how H20 has aged and its appeal fundamentally has diminished. I mean, geez, it's almost been like 6 months, right? Since a lot of the drama around, AI chip shipments to China, which really started with the AI diffusion rule. So I like that it's great that you brought up, Karl, the alleged chip that Nvidia is now working on, that's based on the Blackwell. And that's the next thing I think you have to really look at in order to, as you look at forward to what is the Nvidia China business going to look like, right? It may no longer be H20 from what we can tell. Right.
Mhm.
especially as this drags on. And I
Yeah.
assume that the Blackwell chip, B20, whatever they're going to call it, is still progressing as planned.
Yeah.
And if they can sell it,
Exactly.
great. If they can't, then it's a big waste of money.
Yeah. Well, I mean, Jim, how long do you think it would take for them to turn one around?
No,
It
not
must have
long.
been in the work.
Actually,
It must
I
have been in
actually,
the work.
I would expect, I would expect that it was already in the works, and the fact that they've already got the chip design. That the only limitation is how quick can they get them through manufacturing, which is quite an extensive cycle.
Yeah.
So you're still talking, 3 quarters, 2 to 3 quarters at least, just to get them into production.
Yeah. So great insight. Yeah. This is a cool conclusion to this particular interesting, if not super weird topic of the month. And we're only halfway through, or we are, almost to the end of the month. But Jim, you're at FMS 2025. Number one, what does that stand for?
It used to stand for the Flash Memory Summit. Now it stands for the Future of Memory and Storage Conference.
Okay.
So it's kind of changed, and rightfully so. We tend to think of memory and storage in two different sentences or two different realms, and they really are the same. It's one spectrum. It's what I like to call the data pipeline, or you can call it the data layer, the data level, whatever you want to call it. But you have to think of it all holistically. Everything that goes from on-chip SRAM to, HBM memory to GPU direct storage, main memory, pooled memory through CXL to network storage. All these things kind of make up a single data layer that's critical, especially for AI. Without the
Yeah.
data, you don't have AI. So it's interesting. And it's interesting to see how the discussions around memory and storage are changing drastically.
Yeah.
I would say there are kind of like three common themes at FMS this year. One is power. Power matters. It never really mattered for anything other than the processor or the accelerator. Now every ounce of power matters, and paying a lot of attention to that, especially the big three players, Micron, SK Hynix, and Samsung, all really highlighted that. And Micron, is in a great position in terms of having 20 to 30% power efficiency enhancements over their competition. So
Yeah.
it'll be interesting. The other key themes there was definitely the fact that their AI requires different types of memory and storage solutions for each stage.
Yeah.
So,
Yeah.
whether you're talking about the data acquisition, data processing or ingestion, the training or the inference processing, each one of those has different requirements, whether it's on
Yeah.
the density or bandwidth,
Right.
performance requirements. So, all three were really or I would say all of them, even Kioxia, were highlighting those requirements and others at the event. And the last one was the fact that, things are going to change too,
Mhm.
especially as we start looking forward. It'll be interesting to see how this plays out. Everyone was talking about customization with HBM4,
Mhm.
especially with
Mhm.
HBM4E trying to add in-memory compute with computing resources in the memory. I don't really see how that's going to be
Really? Is
feasible without standards because nobody wants a single source supplier.
it going to be a
But
GPU?
you tell me. And
Well,
there and there's a lot of other innovation going on from
yeah.
high
Yeah.
bandwidth flash, which is, if you're not familiar with that, that's kind of like a hybrid solution that includes HBM DRAM with stacks of HBM flash on top of it to increase density.
Yeah.
There was
Wow.
once again there was talk about pooled memory with CXL. There was talk about GPU
Oh,
direct storage.
okay.
So it is interesting that that data layer, that data pipeline, is becoming a critical importance to AI. And, that's everything that's happening there for the data center is going to filter down throughout the rest of the products, even down to cell phones and stuff like that eventually.
Yeah. 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 Well, the other way around too, right, Jim? Because SOCOM, right?
Oh yeah,
We talked about that and how
trying to use LPDDR in server applications to reduce the memory and also change the configuration rather than having the pluggable DIMMs, having the SOCAM modules. So
yeah.
yeah.
So maybe 2025, or at least this point in 2025, is going to be when everyone realizes memory is important. We kind of had a little bit of that in the memory wall concerns that popped up toward the middle of last year. But I think you're making a really important point here because, Jim, because the diversity of AI workloads, as well as the implications of like novel model designs, have implications on how the system needs to look in terms of memory. And coming out of GTC, one of the big impressions, especially with Dynamo, was the accompanying idea that you're going to have memory tiers that you outlined, and how now we have to think even more. We have to treat this level or dimension of complexity on top of everything else. And so my view, and I don't know what you gentlemen think, this conversation is becoming even more complicated than we have been used to. It is certainly way past just the chip. And so when we go back to the policy discussions and how policymakers need to view the industry, especially AI, this stuff cannot be generalized. And it's also fast moving, right, Karl? Like your piece highlights how quickly everything is just moving so fast. It's mind-boggling.
Well, and Jensen, described it best as the data center is the new unit of compute. There's going to be a lot of innovation at the data center level. It's a single system, whether it's a single building or multiple buildings, it's a single system that you have to think about. And how we design racks, how we cool these solutions, how we power these solutions, how we pump data, how we feed the beast, essentially, how we pump data through these solutions. All this is going to change rapidly, especially as we're trying to reach, 100x performance improvements with each generation.
It's crazy. It's crazy.
It is crazy. But what we're going to do with it is still mind-blowing. I think agentic AI really is a key enabling step for physical AI and robotics. So, where we go from here, I think is almost unlimited.
Yeah,
no, I don't think robots are going to kill us, but that's just my viewpoint.
No, it's because you and your family are going to make sure that they come out with an anti-Terminator algorithm.
No. We're going to come out with the Terminator to make sure he doesn't get. No, just kidding.
Well, I don't know, if you gentlemen want to touch upon this MIT AI report that came out that is like the buzz. Yeah, you want to skip it? You want to cut it off now, or you want to venture into this particular?
Now that you got it out there, we can't just shut it.
I can't help it. You're the one that brought it up, Karl.
Well, I think it, it goes to show that if you think you know how to build your own AI, you're probably going to fail. While the headline, if those who haven't seen it, said that 95% of AI projects, generative AI specifically, projects fail in the enterprise. It also said that something like 67% of them succeed if they use pretty much off-the-shelf tools as opposed to building everything themselves. So that kind of lends to credence to all the software companies that are building solutions that people just plug in with their corporate data. And I'm oversimplifying it to be sure, but it doesn't mean that AI is dead. It means that you probably don't want to start by rubbing two sticks together. You should build on what's already been created and not try to replace it all.
Jim,
I love that description, and it's a lot of it's misconceptions. People not really understanding the bounds, the needs, the tools, everything, and that gets to a key point that when we're in these periods of hyper innovation, it's really hard because things are changing every day, every week, every month. It's changing so rapidly that, you're going to have a lot of that failure, but we're going to have a lot of success too. So I really hope people don't take that out of context of saying AI is bad or AI is dead or we can't use AI. No, you just have to realize that, some of the companies I've talked to recently said, in a lot of cases, we were doing everything ourselves. And then we realized if we just waited 2 or 3 months, Nvidia was going to come out with something and we didn't have to do that part of it. That's a key part of it is leveraging the ecosystem.
Yeah,
The same thing may happen with networking, right? Everybody's rushing to compete with NVLink. And Nvidia, GTC came out with NVLink Fusion. And for those of you who don't know, it basically solves the problem that Nvidia struggled with from the beginning, which is no CPUs, no significant CPUs powered it for a while. But most CPUs, they don't speak NVLink. Right, so you have to go out to a slow PCIe adapter. That's not going to work. Well, NVLink Fusion says, tell you what, Qualcomm, whoever, if you want to build an AI server for a specific solution, you can use our GPU and plug it into your CPU. And here's the IP that'll allow you to build NVLink into your next generation chip. And now
you can even link it to your AI accelerator clusters and everything else. So yeah, they're opening it up through licensing to make it available. So it's going to be interesting.
All the rush to compete with it may just evaporate when everybody says, "Why don't we just use it?"
Yeah, we'll see what happens.
It's an interesting play.
Yeah. Well, I find it absolutely fascinating, Karl, how you took the topic of the MIT AI report and somehow completely
hardware.
Yeah, that was like a hard left.
But it's the example of use what's already been built, and those who do that with AI.
He's just trying to bring it back around to his article that you have to use Nvidia.
Yeah. There you go. I wrote a Forbes Tech Council piece that talks about exactly what you mentioned, Jim, is that you don't need to be first. Just let other people make the mistakes. And misconception is absolutely 100% one of the contributors to failure. And then, I'll be flat out honest here. You have to go and look at who your advisors are. Do that because we're here. We are analysts, and part of our job is to help end users understand who to engage, what in applying these technologies well, and also to be able to be conscious of the various readiness factors that you need to incorporate into your decision making. And that has been a massive failure. And so it's not a surprise that this MIT study highlighted this. And by the way, Karl, so 65% of 5% is only 3%. So it's still pretty bad.
No, it's 65% in total.
But the thing is, the lesson learned here is that you need to be less misguided. And going back to our comments earlier about the velocity of how quickly things are changing. And Jim, what you've just mentioned about innovation, by the way, not all of this stuff is innovation. Some of it's actually you're innovating in the wrong direction, which is just, I don't know, you're just wasting money. But the innovation that is moving the ball forward is moving so quickly. Yeah, you really do need to time based on the application, the value you're trying to extract through the application of these technologies, when and how to get in. But you certainly can't come up with a strategy and shape a program based on misconceptions and misguided notions. And that's, I think, that should be a warning for all those who are listening to us and watching this podcast. And I will have to assert that we are a good source of sensibility here. So start with us, right?
So for those of you watching and listening out there, that was Leonard's long way of saying, don't listen to anybody else, listen to us.
But us. Well, hey, come on. All you have to do is listen to our podcast. We've been calling it. So, and, not just from the standpoint of, the technology, but from a practitioner's perspective as well. I think it's important because it's one thing to just talk about the technology. It's another to talk about how that gets implemented. And there's a lot of choices that have to be made. And, the thing I appreciate about you guys and our collaboration is that we bring that holistic view for our listeners. So anyway, any final thoughts on this controversial piece from the folks at MIT NAND? No? Are we good?
No, I think we're
good.
All right. Okay. Well, this is dragged on much longer than Karl is comfortable with. Going to blame him because he kind of complained earlier, which is fine. It's constructive complaining. So thank you for that, Karl. But hey, everyone, thanks for listening in. If you want to tap into the genius of Karl Freund, contact him on LinkedIn, but most certainly at www.cambrian-ai, and there is a hyphen there, .com. And that is Cambrian AI research, okay? And he is the man. And then, of course, Jim McGregor of Tirius Research. You can contact him at www.tiriusresearch.com. And both of these gentlemen are on Forbes. They're all over the place, so you can find them all over the place. And they don't bite. So feel free to reach out to them, especially if you are looking for the leading edge perspective and advice on all things data center and semiconductors.
And make sure you also reach out to Leonard, Take Two, Lee, for at Next Curve.
Thanks. I really appreciate that help.
That was cute.
I know. That was very, very cute. And just remember to like, share, and comment on this episode. Subscribe, support the podcast so that we can continue, and we'll continue anyways, but to continue to share our industry observations and, dare I say, expertise with all of you. And make sure to subscribe to the Next Curve research portal at www.next-curve.com for the tech and industry insights that matter. And we'll see you next time, actually toward the end of the month. And hopefully we'll have Mario on, and we're going to have another round of fun. Thank you, gentlemen. Have a great day.
Thank you. Have a good one.